get the vertical asymptote of our function, you need to factor the denominator. After factoring it, the factors are x plus 2 and negative x plus 1. Then equate each factor to 0 and you will get the vertical asymptote. There would be x equals to negative 2 and x equals to 1. For the horizontal asymptote, you are going to find the x with the highest degree. In here, the degree of the numerator and the denominator is 2. Thus, to get the horizontal asymptote, simply divide the coefficients of the numerator and the denominator. So, negative 1 over negative 1 is to 1. To end, the vertical asymptote are x equals negative 2 and x equals to 1. Then the horizontal asymptote is y equals to 1.
The function given has an exception. In order to get the exception, we equate the horizontal asymptote y is equals to 1 to the equation. We now have negative x squared minus 2 plus 2 is equals to negative x squared plus x plus 2. Combine similar terms, it will result to x is equals to 0. The graph crosses the horizontal asymptote at a point 0, 1. To solve for the intercepts, we equate x and y to 0. To get the x-intercept, we equate y to 0, then cross multiply. We now have negative x plus 2 times x plus 1 is equals to 0. In conclusion, the x-intercept is equals to 2 and negative 1. To get for the y-intercept, we equate x to 0. And we have 0 plus 2 times 0 plus 1 over 0 plus 2 times 0 plus 1. We have 2 over 2, which is equal to 1. Therefore, y is equals to 1.
There would be critical numbers that will help you know whether the part of the graph or the function is above or below the x-axis. In finding these critical numbers, just factor the function and get the value of x that will make each factor 0. So in the function, the critical values are negative 2, negative 1, 1, and 2. So now, let's make a table of signs out of these critical values. So, assign a value in each column that will satisfy or is within the range of these critical numbers. So for example, if you are going to give a value between negative 2 and negative 1, then perhaps you can have negative 1.5. Then evaluate whether the result would be positive or negative. So simply substitute the assigned values here. For example, in negative x plus 2, 3 plus 2 would be positive. So write a plus sign. Negative 3 plus 2 would be negative. Write a negative sign. Negative 3 plus 1 is negative and 3 plus 1 is positive. Positive times negative, if you can see here in the graph, would lead us to a negative sign. And again, in the denominator, positive times negative is negative. So if we're going to solve it, negative over negative will lead us to a positive answer. Thus, the quotient, which is positive, will tell us that this part of the graph, the one on the left of negative 2, would be above x-axis. So all you need to do is to do the same process on the other values. So, negative, positive, negative, positive.
Graphing comes very simple. Let's start with plotting the x and y intercepts on the graph. So we plot the points 2, 0 and negative 1, 0 on the x-axis and plot the point 0, 1 on the y-axis. Now let's proceed to the asymptotes. We have two vertical asymptotes, which are x equals 1 and x equals 2. So we simply draw two vertical lines on both points, which are parallel to the y-axis. Then, we have one horizontal asymptote, y equals 1, so we can draw a line which is parallel to the x-axis passing through this point. Now we apply the information on the table of signs with the critical numbers. But let us not forget the data from the domain, where the equation is satisfied by all values of x except 1 and -2. Here we can see that the remarks for the numbers to the left of -2 is positive. So it is found above the x-axis. So we can simply draw a curve like this. To be more accurate, we can use test values and simply substitute it. Next we have our numbers in between -2 and 1, which has a remark of negative, which means that the graph is below the x-axis. Now for the values in between -1 and 1, we appear to have a positive remark, so it means that it's above the x-axis. This is where we apply the exception, wherein the graph will cross the horizontal asymptote at exactly 0, 1. We still have the values in between 1 and 2, but with a negative remark. So we can say that the graph is below the x-axis. And lastly, there are values from 2 to positive infinity with positive remarks, which means that it is above the x-axis. So the graph will appear like this. For the behavior of the graph, we have as x approaches -2 from the negative side, f of x increases. As x approaches -2 from the positive side, f of x decreases. As x approaches 1 from the negative side, f of x increases. And as x approaches 1 from the positive side, f of x decreases.